The sound's turned on that way. Yeah. All right. Okay. Today we're going to talk about compound probability when multiple things are happening at the same time. So suppose you're traveling from Philly to San Diego. You think the probability of rain in Do you think the probability of rain in Philadelphia affects the probability of rain in San Diego? I don't think so. Those are two independent events. Okay? Independent events, probability of one does not affect the probability of the other. But if they're dependent events, then the probabilities affect each other. So you have to know when things are independent or dependent. Okay? So let's say you choose a number out of a bag of tiles and you spin a spinner. Are those independent events or dependent events? Independent. Independent. It doesn't matter which tile you choose for the spinner to land on some certain number. Okay? Those are independent. You pick a card from 15 cards and then you pick a different card out of that deck of 15 cards. Is that dependent or independent? That is dependent. Because how many cards are in a deck of cards? 52. If I draw an ace of spades out and I go to draw another card, am I going to have a possibility of getting an ace of spades? No. So the next card depends on the first card that's drawn. Okay? So this is dependent. So you have to know independent versus dependent. Okay. You roll a standard number cube. You roll a die. You know, when you have dice, you roll a die. Okay? Then you flip a coin. Independent or dependent? Independent. A coin is different than a dice. Okay? All right. So if they're independent events, whatever the probability of the first one is, you take times the probability of the second one. You just multiply them together. Life's easy. Okay? So let's say a drawer contains 5 red pens, 6 blue pens, 3 black pens, and 24 silver paper clips. Okay? And 16 white paper clips. What's the probability of selecting a blue pen and a white paper clip? So we start with the pens. How many total pens are there? 5 and 6 and 3. 14. Okay? The probability of a blue pen is 6 out of 14, or 3 out of 7. How many paper clips are there when you have 24 and 16? 40. The probability of a white paper clip is 16 out of 40, which reduces down. 4 goes into each, 4 and 10 times. 2 goes into each, 2 and 5 times. So you got a 2 out of 5 chance of choosing a white paper clip, a 3 out of 7 chance of choosing a blue pen. So if you multiply them together, you have a 6 out of 35 chance of getting both of those, both a blue pen and a white paper clip. Now, and is hugely important. And or mean different things. Right, Kenzie? Okay. You paying enough attention to draw and know what I'm talking about at the same time? Are you sure about that? Okay. We'll have to trust you then. Events that cannot happen at the same time are called mutually exclusive events. You cannot roll a 2 and a 5 on a die at the same time. You roll a die, you get either a 2 or a 5. Okay? So if you have mutually exclusive events, okay, then you add them together. And the key word is or. Or is the key word there. Okay? So, and for independent events or for mutually exclusive events. Okay. Student athletes at a local high school may only participate in one sport each season. So, like in the spring, we have track, golf, and what else? Girls sport. Track, golf, and softball. Okay. Let's say we only allowed one sport at a time. Okay. You couldn't do 2 like Cambry does softball and track, and Savannah does track and golf. Okay? But if you're only allowed 1, then it's mutually exclusive. So during the fall, 28% of students played basketball and 24% were on the swim team. What's the probability that a randomly selected student plays basketball or is on the swim team? So if it's an or, you just take these 2 and you add them up because they're mutually exclusive. You get 52%. In the spring, 15% of the athletes play baseball and 23% are on the track team. What's the probability of grabbing somebody that's either an athlete playing baseball or track? You add them together and you'd get 38%. Overlapping events are events that have outcomes in common. Okay? So, if you roll a dice twice, what's the probability of rolling an even number and a multiple of 3? Well, you take all the probabilities and you figure them out, but then you have to take out a probability that's a multiple of 3 and an even number. So you add one probability to the other, but subtract one that happens twice. Okay, so here's how it works. Suppose you have 7 index cards, each of them with the following letters: A, B, C, D, E, F, and G. Okay? So, let's say A, B, and C belong to the blue group. F, A, C, and E. Cab is in the blue group. Face is in the green group. Okay? Now, A and C belong to both groups. Okay? And D and G don't belong to either group. So what you have is you have 4 letters here, 3 letters here, but 2 of them are used in both words, so you can't count them twice. You can only count them once. So you have 4 letters plus 1 more letter. Really, you have 5 of the 7 letters that you use. So when you add them up, you have to subtract how many are used twice. So if you take the 4 plus the 3, you get 7, minus the 2 that are used twice, you get 5 out of 7. Because if you count 1, 2, 3, 4, 5 out of the 7 letters are used. Okay? So, let me go to the problems now, and we'll see how this stuff works in the problems that you'll see. All right. Boom. Okay, mutually exclusive events. When it's and, you multiply. When it's or, you add. So the first ones are the easy ones. You just add these up. 25% and 63% add up to 88%. And 0.04 and 0.05 add up to 0.9. Mutually exclusive, use the word or, you only use it once. You pick a ball from a basket of red and pink balls. You replace the ball and pick another. Replacing it is a key word here. Okay? If you replace it, as you draw the balls out, are they independent or dependent? Independent, because there's the same amount of balls, there's the same amount of red balls and pink balls if you put them back in. So those are independent of each other. It doesn't matter what the first ball is when you choose the second. Now, a spinner is spun, and at the same tile, a tile is chosen from a group of 10 tiles. What's the probability a spinner lands on an even number and the tile is an odd number? Okay, so how many even numbers do we have on this spinner? So the spinner lands on an even number is 2 out of the 4. And we have to multiply. The number tiles from 1 to 10. How many odd numbers are there from 1 to 10? 5 out of the 10. So you got a 1/2 times a 1/2, which is a 1 out of 4 chance of spinning the spinner for an even number and at the same time choosing a tile that's an odd number. You have a collection of envelopes. 1 red, 3 blue, 2 green, 2 yellow. So how many total envelopes are there? 8 total envelopes. Okay? If you select one at random, what's the probability it is either red or blue? Or means to add. So red is you got a 1 out of 8 chance. Blue, you got a 3 out of 8 chance. So that's 4 out of 8, which is half the time you'll either draw a red or a blue. Okay, how many cards are there in a deck of cards? 52. You have 2 suits that are red, hearts and diamonds, 2 suits that are black, clubs and spades. Each suit is numbered 2 to 10 and has a jack, king, queen, and ace. Okay? What's the probability of selecting a card that is a 6 or a black card? How many 6s are there in a deck of cards? 4. 4 out of the 52 are 6s. Plus, how many black cards are there in a deck of cards? 26 out of the 52. So, there's 30 out of 52. If you divide them by 2, you got a 15 out of 26 chance of drawing either a 6 or a black card.
I will now take my next group for physicals down to the gym. If following students would please report to the gym at this time: Oakley Mees, Carson Wingle, Jackson Sodini, Braylon Optadal, Riley Anderson, Rachel Bonner, Ellie Klein, Aubrey Todkin, and Reese Klein. Please report to the gym.
All right. A math department has 8 male professors, 9 female professors, 10 male teaching assistants, 9 female teaching assistants. If a person is selected from random of the group, what's the probability that the person is either a professor or a male? Now here, there's a crossover. You can be a male and a professor at the same time. Okay? So, or a male and teaching assistant. So, what we do for these is we draw a box. Should have drawn one. There you go. So, in the box, we have professors and teaching assistants. We have males and females. So, how many male professors are there? 8 male professors, 9 female professors, so there's 17 total professors. How many male teaching assistants? 10 and 9 female, so 18 of those. So if we go down 18 and 18, and we've got a problem. 19. Yeah, I can't add. So then there's 36 total people. 36 total people. What's the probability of having either a professor or a male? Now there's 18 out of the 36 people are male. 17 out of the 36 people are a professor, but we counted the male professors twice. So then we have to subtract the number of male professors. 8 out of the 36. There's 18 males, 17 professors, minus 8 of the male professors, because we counted them twice, equals what? Well, that should be 27 out of the 36, or 3 out of 4 chance you're going to either get a male or a professor if you're in a class. Okay? Let's do another one. Vacation. 80% of the students have visited the ocean. 65% have visited the mountains. If 60% of them have visited both, what's the probability they have visited one or the other? Okay? So these, again, are mutually exclusive. Okay? Because you can't be there at the same time. So what we do is we add the two together, and then we subtract what is doubled up. Okay? So we take the 80% that we got for visiting the ocean, plus the 65% for visiting the mountains, minus the 60% that have visited both. So that means 85% have visited either one or the other. Okay. So there's only 8 problems on the worksheet today. Only 8. It will not take you that long. And then next time, what we're going to do is do a quiz review over 13.1 to 13.4. So everything that we've done so far. And then when we get back from Easter, we'll take a quiz over 13.1, 13.4, and then do 13.5 and 13, or then we'll do 13.5. And then Thursday, we'll do 13.6 and 13.7. So we'll get through this chapter basically by the end of next week. And then the next week after that, we'll take review and take the test. Then we'll start on our semester project.